Chapter 11 Test Review. Number 1, the limit as x approaches 8 of x squared minus 5x minus 11. In this problem, you have no problem just substituting 8 in, so this just requires us to substitute 8 in for x, and we get 64 minus 40 minus 1, so that would equal 23. For number 2, the limit as x approaches 5 of x plus 3 over x squared minus 15. Again, we can just take 5 and substitute it in for x. And we get 8 over 25 minus 15, which is 8 over 10, and that reduces to 4/5. For number 3, we have the limit as x approaches 0 of pi squared. Since pi squared is just a constant, then this equals pi squared. The limit as x approaches 3 of x squared minus 2x minus 3 over x minus 3. We cannot take 3 and substitute it in for x because we'll get a 0 in the denominator. So we need to factor first before we take 3 and plug it into our function. So the numerator factors into x minus 3, x plus 1, and then our x minus 3 factors will cancel, and we could take 3 and substitute it in. So the limit will be 3 plus 1, which equals 4. For problems 5, 6, and 7, we're trying to find a limit as x approaches infinity. So you can check your work by taking a look at the degrees of the numerator versus the denominator and finding the horizontal asymptote. So for number 5, the degree on top is smaller than the degree on the bottom, so we know that this will approach 0. But to show the work, we need to divide each term by the largest exponent in the denominator. So we have the limit as x approaches infinity of 10x squared over x to the 4th plus 25x over x to the 4th plus 1 over x to the 4th all over x to the 4th over x to the 4th minus 8 over x to the 4th. And then after simplifying, that will give us the limit as x approaches infinity of 10 over x squared plus 25 over x cubed plus 1 over x to the 4th over 1 minus 8 over x to the 4th. So using our theorem, we know that the top will go to 0 and the bottom is over 1. So the limit as x approaches infinity is 0. For number 6, we'll move down so we have some more room. But we want to divide each term by x squared, since x squared is the biggest exponent in the denominator. So we have the limit as x approaches infinity of x to the 4th over x squared minus 8 over x squared all over 10x squared over x squared plus 25x over x squared plus 1 over x squared. So after reducing, we have the limit as x goes to infinity of x squared minus 8 over x squared all over 10 plus 25 over x plus 1 over x squared. So now we know that anything over an x will go to 0. So we are left with the limit as x approaches infinity of x squared over 10, or 1/10 x squared. So now, as we plug in bigger and bigger numbers for x, this thing is just going to continue to get bigger without bounds. So we know that this is approaching infinity. For number 7, we have a 10x to the 4th in the denominator, so we want to divide everybody by x to the 4th. So we have the limit as x approaches infinity of x to the 4th over x to the 4th minus 8 over x to the 4th all over 10x to the 4th over x to the 4th, 25 x over x to the 4th, and 1 over x to the 4th. So after we simplify, we have the limit as x approaches infinity of 1 minus 8 over x to the 4th divided by 10 plus 25 over x cubed plus 1 over x to the 4th. So we end up with the limit as x approaches infinity of 1/10, and that equals 1